So combined inequalities are inequalities that can be graphed on the same number line, and the solutions in the shaded region can fit any portion for that variable that would be shaded on that graph. So there's two main types of combined inequalities. There are conjunctions and disjunctions. A conjunction is a solution where any value of the variable has to make both inequalities true, and these ones typically are overlapping graphs. And a disjunction is a solution that would work for either inequality. So a conjunction uses and. It has to fit both. So it has to fit this inequality and this inequality. A disjunction uses the or phrasing, where it has to be a solution for this inequality or the other inequality. It does not have to fit both. So first, if we look at conjunctions, to work through them, you can solve or graph each of them separately, and you're looking to see where that graph is overlapping. And the part that overlaps is the solution that's going to fit both inequalities. So in this example here, I've got the inequality here where x is greater than or equal to 0, because I have a solid circle on 0 showing that it's equal to, and it's shaded to the right, so greater than, all these numbers are larger than 0. And this other inequality at this circle, I know that this circle is at 3, so I'm comparing x with 3, and it's shaded to the left, so it's shaded smaller numbers, and this is an open circle, so 3 is not included, so this would say that x is less than 3. So I can see two separate inequalities overlapping, graphed on the same number line. To actually graph them, just think of how you would graph each individual inequality. Graph one and then graph the other, and you're trying to find where they overlap. So in this first one, x is less than 3. I know I'm going to have a circle on 3. And this one is actually an open circle because there's no equal sign here. That means that 3 is not included. And since x is less than 3, I want my solution to have all numbers that are smaller than 3. So that would be to the left here. So all of these numbers are showing a solution for that first inequality. My second inequality is x is greater than or equal to negative 4. So if we look at greater than or equal to negative 4, I know I'm going to have a circle at negative 4. And it's filled in. It's a solid circle because that negative 4 is a solution. So this one has a solid circle on negative 4, and x is greater than or equal to. So I want to also shade to the right, showing everything that is greater than or equal to. And now you can see the solution range is anything between these two numbers. Anything that overlaps is going to represent the solution for this conjunction. In this case, though, 3 is not a solution because that would not fit both. It does not fit this one. 3 is not less than 3. So it still has to have that solid circle. The other example is a disjunction, and disjunctions use or. You have to solve each one separately and then graph them, and you're looking for the value that makes either inequality true. These graphs will not necessarily overlap. So looking at this example, I can see here's one inequality. So x is less than or equal to 3 or negative 3 because it's shaded numbers smaller than negative 3, and it's a solid circle on negative 3. This inequality, x is greater than 2. It's an open circle on 2, so there's no equal sign, and x is every number larger than 2, noted by the shaded region here. So graphing these ones, if you go on your number line, you're just going to graph each of them separately, just like in the other example. So x is greater than or equal to 4. So on 4, I've got my circle, greater than or equal to. It needs to be a solid circle because 4 is included by this equal sign. And x is greater than 4, so we want to shade to the right. And it goes on and on forever in that direction. and then x is less than negative 3. And since there's no equal sign here, it's an open circle on 3. And x is less than or smaller than negative 3, so I want to shade to the left. All of these numbers are smaller than negative 3. So you can see now for my disjunction, the number or the inequalities are in opposite directions. So by this or, my solution just has to fit one of them. So negative 5 is not greater than or equal to 4, but negative 5 is less than negative 3, so negative 5 is a solution. So for these, anything here or here would be a solution to this disjunction. So I kind of showed this already, but to write the inequalities from the graph, when it's a disjunction, it's a little bit easier to see because you can clearly see where the two inequalities are. If you look at this number here, if this is negative 5, negative 6, negative 7, so I know my number is negative 7, and just choose a variable. This one looks like they haven't used w. So w is smaller, so less than negative 7, and there's no equal sign because this is an open circle. So w is less than negative 7. My other example, I know I'm going to have w, and then 5, 6, 7, so this time it's a positive 7. And in this case, it's shaded larger than 7, so w is greater than 7. And this one is an or. W can be less than negative 7, or w can be greater than 7. Anything in the shaded region is a solution to this combined inequality. And then grabbing the inequalities from a conjunction, they're a little bit trickier just because they overlap, but still just look to see where your circles are. So this one has a circle at negative 2, and there's no variable here, so I'm just going to use x. So I'm comparing x with negative 2. I know there's no equal sign because this isn't shaded, and it's shaded to the right. So these are numbers that are larger than negative 2. So x is greater than negative 2 because these numbers are greater. Looking at my other one, I'm comparing x and 5. And this one, it has included 5 because it's a solid circle and it's shaded to the left. These numbers are smaller than 5. So x would also have to be less than or equal to 5. And this one uses and. And the other unique thing about conjunctions is you can write them on one line, write the inequalities as one line. And if you think about how it's written, in one line, here's your first number, here's everything that's a solution, so x, anything in here, and here's your other number. So you can write your inequality that x, start with your number, so negative 2, and negative 2 is less than x. And then if this is our shaded region at 5, x is less than or equal to 5. This inequality here shows the same two things here. Notice that when you look at this one, it's opening up to the x here. This inequality here is still opening up to x. So when you write it, make sure that the inequality faces the correct way. And you can kind of see it here. Negative 2, and then everything in here is x, and then this is 5. You're just filling in the inequalities. Open circle, so it's less than. Solid circle, less than or equal to. If you're looking for more practice in the book, the external link that they have for the book on page 147, here's some more practice problems if you'd like to practice, and otherwise let me know if you've got questions.